These are the notes for Chapter 3, Section 8. Our objective is listed here. It's to find values of functions and to graph functions. So we're going to cover a few terms here. The first is a mapping diagram. Okay, this right here is a mapping diagram. What it does is it takes values in the domain. The domain is over here on the left. We'll note it with a D. And it maps them. In other words, it draws an arrow like so to a particular value in the range. And the range will usually represent with an R. Okay, so that's a mapping diagram. In other words, it maps a value from the domain to the range. For instance, 3 is mapped to 5, or -1 is mapped to -3, and so on. A function is a new word for us. We've probably heard it before, but not quite known what it means. So, a function is a correspondence between two sets D and R that assigns each member of the domain, D, the domain, exactly one member of the range. Okay, functions are sometimes specified by a rule. The rule for the function in the diagram is double the number and subtract 1. So it's talking about the rule for this diagram. It's double the number, so that's 2 times the number, and subtract 1. For instance, right here, 2 times 1 minus 1 gives us 1. Or for there, 2 times 0 minus 1 is equal to -1. Okay. So a function is basically a rule. It takes one value in the domain and tells you what to do to the value in the domain to get the value in the range. Okay, so note we want to be specific. It says exactly one member in the range. That'll come important for us here in a little bit. The domain of a function is the set D. They use D. That so it's basically all the values we can plug into the function. And the function above the domain was the integers. The integers are values like -3, -2, -1, 0, 1, 2, 3, and so on. The range. The range of a function is the set of all members of R assigned to at least one member of the domain. The range above is the odd integers, 5, 3, 1, -1, -3, -5, and so on, the odd integers. The values of a function are the members of the range of the function. The graph of the function, this is a new one. The graph of a function is the set of all points xy such that x is in the domain of the function and the rule of the function assigns y to x. We've got two different types. The first is arrow notation. It looks like this. Okay, we read this as f is the function that assigns 2x minus 1 to the number of x. In other words, our input x, we double x and subtract 1. We also have what we call functional notation. Functional notation looks like this. Okay, the value of the function f at 3 is 5, or f of 3 is 5. And in other words, they give us sort of like an ordered pair, and that ordered pair is 3, 5. If we input 3, we get 5. That's what this means right here. We get the ordered pair 3, 5. So, our first example here. Given f, where x is assigned to, or x squared minus 3x, right here, the function f. Okay, so we're going to look at this. This is how we read it, the function f. And so we're looking here, the function f that assigns x squared minus 3x to the number x. So in our particular value f, we want to find the range of f. So we'll do that. So I'm going to make a table. I'm going to have x. What does x do to my function f? It does x squared minus 3x. So my domain, that's what x is. -1, 0, 1, 2, and 3. For each of these, we plug in -1, 2, and 0. I'm going to change some colors here just to get those lined up. We'll change that, and we'll change that to red. Okay. So everywhere we see an x, we put our x value for each one. So note, we do the same operation regardless of the x value. So I plug in -1, -1, 0, 0, 1, 1, 2, 2. I skipped out on 3 here. Should have given myself enough space. Let's see if I can fix this here. Up, up, and over. Okay, good. Where we are at this, that's 1, that's 2, 3, we'll put here. Okay, squared minus 3 times its input, and our input is 3 here. Okay, so we can do that math. And what do we get? We get -1 squared. -1 squared is 1. -3 times -1 is +3. 0 squared is 0. Minus 0. 3 times 0 is 0. 1 squared is 1. Minus 3 times 1 is -3. 2 squared is 4. Minus 3 times 2 is 6. 3 squared is 9. Minus 3 times 3 is -9. So I get 4, 0, -2, -2, 0. Alright, so what does that mean? It means we want to find the range. We will write the range like this. R, the values, -2, 0, 4. That's our answer. Now, what we're going to do is we're going to graph the ordered pairs. Well, what ordered pairs might you be saying? Well, the ordered pairs are -1, 4, 0, 0, 1, -2, 2, -2, and 3, 0. A note about the range up here. I have -2 twice. I have 0 twice. So I only have to write each of those once. Now, the ordered pairs, I take x and the output, x and y, x, y, x, y, x, y, x, y. So I take those and I want to graph those. -1, 4. That's left 1, up 4. 0, 0. Don't move off the axis at the origin. 1, -2. Right 1, down 2. 2, -2. Right 2, down 2. Oh, that last one was off a little bit. 1, -2, 2, -2, 3, 0. There's a pattern here, and if you can pick up the pattern, you might be able to figure out that the next point, if we were going to graph one, would show up here because it's symmetric, but we're not doing that right now. This is the graph of our ordered pairs. We have graphed F. Graph of F with our domain D. Okay, notice there are no connecting lines. I guess I need to make this smaller. No connecting lines. If you connect the dots, you will lose points. Okay, so your homework is to do the same type thing, and I'll talk about the first one here. What you do is you take your function x, you make a table, 3x minus 2, and for each of those you plug in -1, 0, 1, and 2. Now again, we'll do this in class. You'll have time to work on this in class, and then we'll take a quiz on this. Okay, so your first 10 problems are to find the range and then to graph the functions. So I'll leave those for you to do. If you want to start on them, you can. Now, the other homework you have, the other type of problems is you want to give, or the other classwork we'll work on is give the domain of each function. Now we have guidelines here. The guidelines state that we want to begin with a set of real numbers. This is all real numbers. Then the second thing we do is we eliminate any of these that don't produce a real number when substituted. So we have to sit here and we have to think, what things might cause an exception? Okay. Things that cause an exception. Okay, well, first one we want to think about is if we divide by 0, that's an issue. Second thing is that we take the square root of a negative number. That's also an issue. Those are the two mainly we'll look at. There's other stuff out there, but we won't tackle those yet. So, the idea is we have problems here. Let's look at the first one. The first one, right here, we want to find the domain. Find the domain. We have division. Okay, that means divide by 0. So that means x squared times x minus 5 cannot be equal to 0. Okay, so if y'all remember your zero product property from Algebra 1, it means x squared can't be 0 or x minus 5 can't be 0, because if two things multiply to give us 0, one or the other is 0. So x can't be 0 and x can't be 5. And so the domain, we would write all real numbers, or I'll just say all reals, except 0 and 5. Okay, that's our answer. All reals except 0 and 5. That's the domain. That is our domain. We only had an exception if we divide by 0. The only numbers that will mean we'll divide by 0 is when x is 0. When x is 0 makes x squared 0, and 0 times anything is 0, so that makes the whole thing 0. Or when x is 5, we get 5 minus 5, which gives us 0, the whole thing 0. So, those are our exceptions. That's our answer. Domains all reals except 0 and 5. We do the same type thing here. We've got division. Division. Okay, so that means we want to look at divide by 0. That means x squared plus 1 cannot be equal to 0. Solving this out, we subtract the 1. If I subtract the 1, I get x squared. 0 minus 1 is negative 1. Well, there is no way for x squared to be equal to 1 or negative 1. We don't know how to do that. We'll cover it later. We'll learn how to do it, but right now we don't know how to do that. X squared can't be equal to negative 1. So if x squared can't be equal to negative 1, that means x, there isn't a value for x to make x squared equal negative 1. Okay, so that means there are no exceptions. All right, no exceptions are good. That makes our domain all real numbers. So I'll just say all reals. So that's your answer. The domain is all reals. All right, back up here. Domain's all reals. We're dividing by 0. X squared plus 1 can't be equal to 0. X squared can't be equal to negative 1. No way for x squared to be equal to negative 1. So there are no exceptions. The last one we'll look at here, we've got a square root. That means we can't have, means no negative. So that means x plus 1 can't be negative. In other words, x plus 1's got to be greater than or equal to 0, or x has got to be greater than or equal to negative 1. Subtract the 1 from both sides. 0 minus 1 gives us the negative 1. So x is greater than or equal to negative 1. So how do I write my answer is what you're asking. What am I looking for as a solution? The domain is all reals greater than or equal to negative 1. That's your answer. Okay, and so your homework on these last ones, or the classwork we'll do, are given the domains. Now, what you look at here is the first one, like here, there's no exception. No division, no square root, so there's no exception, so it would be good. We've got division on the second one. division here, so we look for divide by 0, division here, divide by 0, division here, divide by 0, square root, what's underneath can't be negative, square root, what's underneath can't be negative. So again, you don't need to work through these now. We'll work through these tomorrow in class. Okay, and I will see you tomorrow.